Greetings, this is Charles with Phenomenware, and I'm back for my second video, and I thought it would be fitting after the first video to follow up with an explanation of computer science, since that's one of the primary focuses of my channel and something I'm really passionate about. By the time you watch this video, you'll have a brief understanding of what computer science is, why it's important to teach it, and how it's transformed the world that we live in. So let's jump right in. There seems to be a major focus on computer science these days. So, what is computer science, and why is it important that we teach it?
According to Wikipedia, computer science is the study of the theory, experimentation, and engineering that form the basis for the design and use of computers. It is a scientific and practical approach to computation and its applications and the systematic study of the feasibility, structure, expression, and mechanism of the methodical procedures or algorithms that underlie the acquisition, representation, processing, storage, communication of, and access to information.
Do what? What does this even mean? See, this is the reason why people are afraid of computer science and programming. And it probably doesn't help that they picture this.
An alternate, more succinct definition of computer science is the study of automating algorithmic processes that scale.
Okay, so let me break this down in layman's terms. So computer science is the study of the foundation of computers and how they're programmed to process information. Typically, when you hear about computer science, you hear about coding, and you see something like this.
So all of this code is written by people. Now that code is basically like small building blocks or recipes or blueprints that tell the computer how to deal with input and output. That input, whether it's from a keyboard, mouse, gamepad, stylus, microphones, cameras, or even the touch of your finger, can be analyzed and processed however a programmer decides. All it takes is that you familiarize yourself with the proper code language that fits your needs. Coding is what we use to make computers simulate the senses that us humans take for granted every day. We simply move our body parts and use our senses almost involuntarily while our brain is processing millions of instructions per hour. It's more difficult to make a computer do the things that we do. But with the proper training, you too can become a computer programmer.
Now, speaking of computer programmer, you've heard of similar terms, right? Coder, developer, software engineer, computer scientist. I've even heard the term script monkey. But how do you become one of these?
The best way is to start with a programming language, such as JavaScript, Python, Java, C#, or Swift. But how do you know which language to focus on? Well, that depends on what you want to develop. For instance, if you're interested in developing games for Windows, you probably would be most interested in, let's say, C#. If you're looking into developing iOS apps, then Swift is the way to go. Looking for web? Study the various JavaScript frameworks. In the past, the best general purpose language to learn was Java, but I believe Python has taken its place because of its ease of use and simplistic syntax, and that really bodes well for teaching.
Whatever the language you choose, start small and learn the basic syntax first.
Most learning resources follow the same structure. First, they teach the basic syntax of data types, then operators and conditionals, loops, functions, sometimes complex data types such as structs, then classes and object-oriented programming, and so on. And gradually you move on to more complex topics such as object inheritance, polymorphism, and data structures, which is the study of searching and sorting data.
All of these concepts sound like a foreign language if you're new to computer science. But the same holds true if you try to teach a 5-year-old how to build a house. Looking at programming documentation would be like taking a trip to a local home improvement store. Without a detailed plan or blueprints broken down into smaller pieces, it's almost impossible to know where to start. Talking about hammers and nails is one thing, but a child is quickly overwhelmed when you start talking about drill presses and laser levels and sledgehammers and measuring tools, nail guns, So enough of the jargon. If you're interested in learning how to code, here's some helpful resources. Now, these are some sites I've used over the last few years to enhance my programming knowledge, and I think you'll benefit from them as well.
Code.org, Codeacademy.com, Lynda.com, Pluralsight.com, RayWenderlich.com, Khan Academy, Udacity, Udemy, DevSlopes.com, Stanford Computer Science on iTunes U, and of course, YouTube. There are many other sites out there, but these are the ones that I've used throughout the years.
So why is this such an important time to teach computer science? Well, let's talk about artificial intelligence, or AI. Now, this can be a loaded and lengthy topic, so I'll discuss it briefly. When I was in high school, I gave my senior talk on artificial intelligence. I created a tic-tac-toe game with 3 levels of difficulty, and it showcased basically how AI worked many years ago. Level 1 made decisions randomly, and complete randomness was not very intelligent. So it was a great way to showcase the beginning level of artificial intelligence in a game. Now, level 2 was a little bit more intelligent in that it knew some of the rules. It was able to take some of the tic-tac-toe rules, and so it randomized half the time, and the other half the time it used the official rules to actually play against the player. Now, in level 3, the CPU got first move, and it understood all the possibilities, and of course, the computer would always win unless the player was good enough to tie the game. At that time, which was roughly 21 years ago, this was the basis of programming in AI. The saying was, the computer is only as smart as the people programming it, only faster at computation. Things have changed a lot in 21 years. Over time, computer processing power has increased significantly, allowing the analysis of data to happen exponentially faster and at a much larger scale. So here's how it works now. By providing computers with a large set of data, it can learn from repetitive analysis. Think about how we train a toddler to recognize a flower.
Tell the toddler, flower, and give it a visual representation of various types of flowers over a period of time. What does the toddler do? It will begin to recognize the characteristics of what it sees. It will associate those characteristics to a flower. Things like its color, shape, size, the fact that it has petals, and seeing a set of flowers allows the toddler to make a memory of what we call a flower. Even if you present a new flower the toddler hasn't seen yet, by continuing this training, its brain will assume that it's also a flower. But what if the perception is wrong? Well, as a parent, we can explain, no, that's not a flower, and proceed to tell them what that other object is. The same holds true with artificial intelligence on computers today.
So obviously, the tech industry is booming with jobs for computer science majors. So over the next few videos, I'm going to show you a few articles that I've found that showcase how computer science has advanced a few industries over the past decade.
I hope my videos are informative, that you can learn from them, and that they are enjoyable to watch. If so, get real familiar with that like button and make sure to subscribe to my channel. Stay tuned for the next video.